All right. I've got another problem for you. This is not an exponent property problem. This is going to turn synthetic substitution into synthetic division. It's a really cool, powerful tool for finding solutions or finding factors to polynomials. It's a lot of fun, believe me. Okay, so we're given this polynomial, y equals x cubed plus 3x squared plus x minus 5. And the instruction is to find all real and imaginary zeros. Now, we know a real zero is the place where the graph crosses the x-axis. Other names for zeros are x-intercepts, roots, or solutions. An imaginary zero is harder to see because we don't graph them on our real coordinate graph. So we're going to have to find them in different ways. So with this problem, one method of starting to solve it is to use some sort of graphing utility and graph. So the one on the right came from a website on the internet, wolframalpha.com. The one on the left is the sort of screen that you'd get if you're using a TI-83 or TI-84. Any graphing utility will give you an answer, or a picture rather. So what I want to point out here is that on either one of these, we notice when x equals 1, y equals 0. This is a solution, or a 0, because it's something that makes y equal 0. Now, how could we use that little piece of information to find the other zeros? Well, let's take a look. So what I've set up is synthetic substitution. I know that if I plug in 1, I should get 0. So let's check that out. Drop down the 1. Remember, I'm always multiplying anything at the bottom by this number at the left, and then placing that in the next column. So 4 times 1 is 4, and I get 5. Now, you're comfortable with why this is the remainder, or why that's the value when you plug in x equals 1, you get y equals 0. Now, what we've talked about a little bit is how the rest of this stuff actually means something. So here's what it means. This is a way of doing division. What it means is that if you take x cubed plus 3x squared plus x minus 5 and you divide by x minus 1, you're left with x squared plus 4x plus 5. If you want to verify that, what you can do is you can take x minus 1 and multiply by x squared plus 4x plus 5, and I will bet my bottom dollar that you end up with this polynomial. So what we're trying to do here is we are trying to solve for any remaining zeros. We look at this new quadratic and we say, is there any way I can make this 0? Now you have all sorts of ways that you know how to solve quadratics. For example, you may remember using the quadratic formula. Sometimes we factored. This one doesn't factor because there's nothing that multiplies to 5 and adds to 4. Because I think it's good to continue thinking about it, I decided to look at this one by completing the square. So 1, do you agree that x squared plus 4x plus 4 is a perfect square? It is x plus 2 quantity squared. I hope so. And then if I want x squared plus 4x plus 5, I have x plus 2 quantity squared plus 1. Again, I don't know that you would necessarily use completing the square to solve this. You'd probably use the quadratic formula. But it's still there. Completing the square didn't go anywhere. You're going to need to use it later on in your math career anyways. Okay. So I actually went through and I solved this. You You would subtract 1 from both sides. You'd take the square root of both sides, and that gives you plus or minus I, positive or negative I, sorry. Positive or negative I equals x plus 2, or x equals negative 2 plus or minus I. So this problem has 3 real and imaginary zeros. That has to be true because it is a cubic. There should be 3 answers. They are x equals positive 1, x equals negative 2 plus I, and x equals negative 2 minus I. All right, hopefully you got some of that. I would be happy to answer any questions you have about it. Talk to you soon.